So for question 12, they're given us an equation here. Try to show d2y dx squared dy dx. So our first derivative is here, our second derivative is here. Then look at our question. So this will be our explicit questions. Explicit. So you can see what is explicit because y. They just only have a y here. Y subject as a subject, then y expressed all in terms of x. So we look at our x here because we are going to differentiate it with respect to x. You can see our question dx. dx means we are going to differentiate it with respect to x. Okay, refer to the x. We have a x linear. Then we have a x in terms of exponential. So we have two functions multiplied together. So linear x and exponential function, they are multiplied together. So means that they are in product. So multiply means product. So from here, if you want to differentiate our product form of the questions, we have to use product rule. So start with our product rule. Start with our question first. Okay, so set up our product rule. If you want to start differentiation, we'll write dy dx. Start our product rule. So salin yang depan, differentiate yang belakang. Tambah salin yang belakang, differentiate yang depan. Depan is x, so 1 only, simple. Then we differentiate the part that we want. Okay, repeat again. So this is the rules. Salin yang depan, differentiate yang belakang. Nanti jawab lah sini. Salin yang belakang, differentiate yang depan. Okay, so sekarang nak jawab differentiate yang belakang. Differentiate exponential at this part. So the rules of differentiate exponential, it will be salin soalan, differentiate power. Okay, salin soalan, differentiate power. That will be the rules of differentiation applying on the function involving exponential. Then we're going to differentiate yang depan. So differentiate depan x, we get 1. We get 1. Okay, coefficient is leaving 1. Then we're going to simplify it. The way to simplify it, always remember, if can, we're going to factorize it. So we can see we have same factor here. We have a factor e3x, e negative 3x. We also have a factor e negative 3x. So it will be easier if we factorize it. And then we manage to simplify. So we factorize our e negative 3x. What is remaining in the first term here? When you take out e negative 3x, we have negative 3x. So at the second terms here, when we take out e negative 3x, take out means our factorize, we will be remaining 1. So plus 1. Okay, that will be our answer of d2y dx squared. We're obtaining our this part. Then we try to differentiate it again. So based on our result from dy dx here, we analyze what is our x. What is our x function? Our x function in the first function is exponential. Multiply, our x function is linear function. Okay, so we just have two functions multiplied together. So again, we will use our product rule. Okay, so this is our function at the front. This is our function at the back. So two functions multiplied together, product rule. Salin yang depan, differentiate yang belakang. Then salin yang belakang, make sure you put bracket because it has two terms here. Put bracket, salin yang belakang, differentiate yang depan. So salin yang depan, differentiate belakang. So differentiate belakang, negative 3x. Differentiate a constant, coefficient negative 3x, we get negative 3. Differentiate constant here, plus 0. So negative 3 only. Then you're going to differentiate yang depan here, exponential. So we repeat again, the rules of exponential is salin soalan, differentiate power there. Okay, so we done our process of differentiation. Now it's going to simplify. So if we want to simplify, we have to find out which one of the factor they are same. In the first term in the second term here. So in the first term, obviously we have e negative 3x. Here also we have e negative 3x. Then we have constant negative 3. We also can factorize out. So therefore, here we're going to factorize their common factor, which is negative 3, e negative 3x. So for the front part here, for the first part here, after we take out this, it will remaining 1, constant of 1. It's not a 0, yeah, because 0 times anything becomes 0. So when you factorize everything out, here remaining a constant 1 plus. So for this part, this take out already, factorized already. Here we have negative 3x plus 1. So it becomes negative 3x plus 1. So we simplify here, plus 2. So this is our second derivative. Okay, so after we get second derivative, first derivative, so we're going to show this. So when we have explicit equation, okay, showing we have two methods. So showing we have two methods. One is substitution method. Another one is multiplication method. So according to our experience in our past year, so after we do, normally explicit equation substitution will be easier. If we have implicit differentiation, then multiplication of solving will be easier to prove, to show something. Okay, so for this explicit equation, we will try to use our substitution method so that to show this equation, get to the answer 0. So we will substitute all the results, substitute the second derivative result, first derivative result, and y equation, and then we do the operation adding them together so that we can manage to prove it 0. So we will start writing our question like this. We will start writing the question d2y dx squared plus 6 dy dx and then plus 9y. So don't write 0 because the 0 is the part we want to show until it is answer getting 0. If you write your part equals to 0 means you are not showing. You're directly using the equation already. Okay, so you're applying something. It's different concept from showing something. Showing something means you have to do your calculation to obtain completely this part. Okay, from the part completely equals to 0. So that will be the part of showing. So we're going to plug in our result. Here we get negative 3, negative 3x, negative 3x plus 2 plus 6. We plug in our result from first derivative, which is e negative 3x times negative 3x plus 1. Then 9y. So we plug in our y equation. So from here, how are we going to simplify so that we get 0? We find out the same factor that we have. Okay, so what factor that we can find out here? So look at our terms. We have to identify our terms. So this is our first term plus another term plus another term. So we have 3 terms here. So we're going to see we have factor of e negative 3x commonly in these 3 terms. And then we have a constant 3. So this is can take out constant 3. This one can take out constant 3. So we will going to factorize out 3 e negative 3x. So So after we take out this vector 3e negative 3x, what is remaining? We have a negative here. So negative times this will become positive. Then negative times 2 become negative 2. Okay, so for this 6, we take out 3. Then 2 will times this. And then 2 will times 1. Then lastly, we take out our 3 from 9. We have a 3 here. So we'll plus 3. 3x. This factor we already take out. So finally we can see 3x plus 3x minus 6x cancel each other. Okay, we're getting 0. And then 2 plus 2, negative 2 cancel each other. So what we will have here, it will be 3e negative 3x times 0. Therefore, everything becomes 0. So this is how we show our equations.